We're going to look at calculating arc length with sectors, or the information of sectors. So we'll read our question here. A sector has an area of 314 centimeters squared and a radius of 10 centimeters. Determine the arc length of the sector. So let's get our important information out of this. We have a sector which has an area of 314 centimeters squared, and whether the sector has a radius, the radius of the sector is the same as the radius of the circle. It doesn't change, right? So the radius of the entire circle is 10 centimeters. Determine the arc length of the sector. Okay, so arc length is referring to area around the circle, distance around the circle, I shouldn't say area. In other words, otherwise known as the circumference. So here's our hypothetical circle here. A sector, we don't know the degree of the sector, we don't know the portion of the circle it is, so I'm just making an estimate here. We're going to call that sector A. Okay, so this is probably not the scale, but here's our sector A. Highlight it, color it in here. Okay, so sector A has an area of 314 centimeters squared. So 314 centimeters squared. We also know that the radius of the circle is 10 centimeters. So that would be the distance from here to here is 10 centimeters. Well, what is the arc length of this sector? Okay, so we need to figure out what portion of the circle this sector is taking up, first of all. We then need to figure out sorry, I was just thinking ahead for a second. We all then need to figure out what the circumference of the circle is, and then we got to take that portion and calculate the arc length of it. So there's quite a bit of work to this. So the first thing we're going to do is figure out the area of the circle. So the area of a circle is pi times r squared. I just realized I chose a number that's not ideal for this. That's why I did that little pause for a second. I am going to switch this up very quickly. I did this purposely to make the numbers easier, and then realized I pretty much made a sector that is the entire portion of the circle. We're going to slim it down just a little. We're going to say that it's 300 centimeters squared. Okay? We'll just say it's 300 centimeters squared. You'll see in a second why. So the area is equal to the constant pi times the radius, which we have at 10. And then squared. Well, 10 squared is 100, so we're looking at 100 multiplied by the constant pi. So the area of the total circle, we'll go to our scientific calculator here, is 100 multiplied by pi, and look at that, 3.14.15. If you remember, I had the circle's area, or the sector's area at 3.14, which would have been like 99% of the circle. It's still going to be in the 90s, but I'm going to take this specific amount, okay? At least it's a bit smaller of a portion. V, there's our wonderful area of the circle, okay? And we're going to round it. I'm just going to make that a 6 and slice off the rest of that, okay? So it's 314.16 centimeters squared, the entire area of the circle. Great. So let's build a little bit of a ratio here. We're going to take a ratio that's going to deal with, we'll call it area of sector divided by area of circle. Think of it as area of a portion divided by the area of the whole, essentially going to give you a percentage. So percentage, how much of the sector, how much of the circle this sector takes up. I can already tell you this is definitely not to scale, okay? So area of the sector, well, the area of the sector was 300. And the area of the circle was 314.16. In fact, we could be super, because I have this answer here, I can actually be much more exact. I can take the number 300, and I can divide by my answer from the above, and there we go. 95.49 is about 95.5. For simplicity's sake, I'm going to round it to approximately 95, or 0.95, which is also known as 95%. So obviously this is a terrible representation of it. If anything, it would make far more sense if I now did this. Let me get that sec. That's the part. I want to take that away. Probably looks something like this. I'm going to delete these two things. And we'll say that the yellow part is actually outside the sector, and the white part is, there we go, the white part is the sector we're referring to. There we go, 300 centimeters. That's now sector A. Get rid of these highlights. Okay, so this is now sector A. Bring this over here. I know you can't do this on a piece of paper. I apologize if you originally drew your notes the way I had it. We'll say yellow is the part outside the sector, and white is the part of the sector. That is sector A. So we know it's about 95% of the circle. Determine the arc length. Well, in order to get arc length, we also need the formula of circumference. So how do we calculate circumference? Circumference is usually written as circumference is equal to the diameter times pi. Again, we don't have diameter, but we do have radius. Okay, we have a formula that says the diameter is equal to 2 times the radius. In our case, the radius was 10, so 2 multiplied by 10 is equal to the diameter, while the diameter is equal to 20 centimeters. Perfect. Okay, so circumference is equal to 20 pi. Very nice. So our circumference of our circle is going to be, take it over here, go to the next line, 20 multiplied by pi is equal to 62.83, so on and so forth. Plug this number in here, 62.83, we're going to round it. We'll say it's approximately 62.8, okay, centimeters is the circumference of the circle. Great. So if the sector is 95% of the of the area, that also means it's 95% of the circumference of the circle. So how could we have set this ratio up? Well, we could have said that the area of sector divided by area of the circle is equal to arc length GTH of sector over, instead of saying arc length of the circle, we know, because the circle is the whole of something, we know it's the circumference. Hopefully I got that right. Okay. So let's plug in some of the information we have. Area of the circle, we already know what it was, 300, and the area of the sector is 300, area of the circle is 314.16, so let's plug those in. So 300 divided by 314.16 is equal to, arc length of sector is actually our unknown, that's what we're trying to solve, but the circumference is 62.8 centimeters. Okay. Now we already divided this on the outside, and it was approximately 95, or 0.95 as a decimal, is equal to x over 62.8. And of course, you could be far more accurate. We could have gone over and actually took the entire 0.9549296.5. Obviously, you can be much more accurate. I just kind of rounded up here. I probably should have rounded to 96-ish, as the 5 would have rounded up. Anyways, to isolate x. To isolate x here, we're going to take, we have a division sign here. We need to multiply when we move it to the other side. Think of it as if you're multiplying both sides actually by 62.8. On this side, when you multiply it by 62.8, they, known as canceling out, creates technically a 1, and 1 times x is just x. So we have x is equal to 62.8 multiplied by 0.95, which is equal to, it's going to be pretty close to maybe 60. Let's go back to the other side here. We're going to take that answer, and we're going to multiply it by, can I take this number from before? Let's see. Oh, what a guess, right? That's 60. So that was a very accurate answer. I took I know I rounded when I was writing it down, but in our calculator I took very exact answers. So the arc length is going to be 60, and the units were centimeters. So in this case, the arc length of that sector is 60 centimeters out of the total circumference of 62.8